Howdy, calculates. So we're continuing on with optimization problems, and here are some strategies that hopefully will help you. So as you read, of course, you want to pay attention to things like area and volume, because those are hints at what formulas you should be using, so that you can first write a primary equation. And then eventually at some point you don't want to have too many variables in it, so you're going to have to write a secondary equation that'll help you get one of those variables in terms of the other. Like we were doing in yesterday's notes, we were substituting in for length using W, or we were substituting in for height using R. So solving for one variable. And then last, I'm going to end up using probably some calculus to do some maximizing and minimizing on my functions. So let's look at some examples. So I've drawn a picture of f of x equals x squared, which of course is a parabola, and I've plotted the point 2 comma 1/2, which is clearly off of it. And if I want to find a point that's closest to it, obviously the shortest distance is a straight line, and it would have to be perpendicular. So I drew a little square in here. That's the purpose of that, to show that my line is in fact perpendicular. So now here's what I know. On that parabola, that point is x comma x squared, because the y value is x squared. So if I want to know this distance, I'd have to use my distance formula, which is nothing more than Pythagorean theorem. And oh, by the way, it doesn't matter what order I put the x's in, because I'm going to square it anyways, and it doesn't matter what order I put the y's in, because I'm going to square it anyways. So I have 2 points. I have this point, and I have this point. That's what I'm trying to find the distance between. So I'm going to plug them in. So I'm going to do 2 minus x and 1/2 minus y. Noting that my y value is really x squared. So if I FOIL out the inside, I get that big long expression, check my math, and then I note, oh, the x squareds are going to cancel, and so now I can combine some like terms, and it would make sense that since there's my distance, it'll be the smallest, or it'll be minimized when the inside is the smallest. So I'm now going to work with the inside, and I would want to minimize that, so that means I'm going to need to take the derivative so that I can find critical points. So the derivative of that inside looks like this. And if I set it equal to 0, of course I can factor out a 4. And I go, oh my goodness, that's a difference of cubes. So that's going to factor to x minus 1. Remember, I'm using SOAP and then square product square. And of course, this second piece doesn't factor. I'll have to use quadratic formula on it, although I believe it's going to give me a negative under the square root. But this first factor solves nicely. So I get x equals 1. And so then, if I know my x value on the curve, I can plug it in to find my y value. So the point that's closest is 1, 1. Awesome.